On this question, we have a quadratic situation because we know that this is some variation of ax squared plus bx plus c, which is what a quadratic looks like. And a quadratic, if you were to graph it, would be a parabola. And when you're being asked for the number of solutions of a quadratic, that's a reference to the idea of the discriminant. Now, the discriminant is part of the quadratic formula, which we have right here. Now, if you don't have the quadratic formula memorized, you have to memorize it as soon as possible because it's on the SAT, but it's not provided to you. So you have to have it memorized. Now, we're just going to use invented numbers here. So these numbers have nothing to do with the question to demonstrate what happens with the discriminant. So if I had 2 plus or minus root 4 over 3, 2 plus and minus root 0 over 3, or 2 plus and minus root negative 4 over 3, what we're doing is we're having a positive, 0, or negative discriminant. And in the positive side, we would be adding 2 plus 2 over 3 and subtracting 2 minus 2 over 3, and we would get either 4 over 3 or 0. So when the discriminant is a positive number, you end up with 2 solutions. In the next one, when the discriminant is 0, we're not really adding or taking away anything because there's a 0 there. So we would have one solution. It would be 2/3 in this situation. And when the discriminant is a negative number, well, we're not allowed to have a negative under a radical, so that's a deal breaker. There are no solutions in that situation. So we need to find out in this question whether the discriminant, the b squared minus 4ac part, is positive, 0, or negative. So let's just set up the expression b squared minus 4ac, and we can see here that the a is 8, the b is minus 8, and the c is minus 2. So b squared minus 4ac is negative 8 squared minus 4 times 8 times negative 2. And negative 8 squared is positive 64. And in this part, we have two negatives, negative 4 and negative 2. So two negatives make a positive, and it's positive 32 times 2, which is 64. So 64 plus 64 is 128, and we have a positive discriminant, which means that we have two solutions.